Assalamualaikum and a very good evening to examiners Dr. Sheila, Dr. Warafiza and Dr. Rohani. My name is Maisarah Ahmad Sofi. My metric number is S52316. I'm in Bachelor of Technology Environmental under Faculty of Ocean Engineering Technology and Informatics FTKKI. My project title is Studying the Effect of Fiber Size on the Mechanical and Thermal Properties of Empty Fruit Punch EFP fiber reinforced epoxidized palm oil EPO composites under supervision of Dr. Rahani binti Mustafa.
Those are the presentation's outlines. Composite industries are most important to general economy sector in many countries around the world. According to Richard 2005, application of composites in several main industries such as constructions, furniture, aircraft, boats, automotive and many more. In recent years, the application of natural fibers increased, which has been used as a reinforcement in the thermoset composites, where it is affordable and lightweighted materials that used in various industries such as automotive, furniture, food packaging and other industries. Furthermore, the application of epoxy resins in fabrication of composites are increased recently, where it is in manufacturing industries. Nevertheless, epoxy resins are naturally fragile and it is derived from petroleum resources which is non-renewable. Those are the problem statements in this study. First, using synthetic epoxy resin are still considered not environmentally friendly. Therefore, epoxy resin that based on resource that can renewable resin are firmly required. Nonetheless, vegetable oil-based epoxy resins have some limitations rather than petroleum-based epoxy resins. Second, the effect of synthetic fibers could cause numerous environmental impact issues that contributes to these revolutions. Therefore, the use of natural fiber as reinforced composites is strongly needed in order to sustain our environment. Third, the size of fibers is a significant indicator to give impact on the mechanical and thermal properties of the composites. Thus, different sizes of fibers are required to investigate impact of the composites on the mechanical properties, which are the hardness and strength, while for the thermal properties are the moisture content and the thermal stability of the degradation temperature. The objectives of this study are: first, to fabricate the empty fruit bunch fiber reinforced epoxidized palm oil composite. Second, to study the effect of fiber size on the mechanical properties of empty fruit bunch fiber reinforced epoxidized palm oil composite. Third, to analyze the effect of fiber size on the thermal properties of empty fruit bunch fiber reinforced epoxidized palm oil composite. Scopes of the study. First, fabricating the bio-based resin, which is blended epoxy and EPO, will be prepared with a different amount of EPO, which are 10 and 20 weight%, will replace a part of epoxy resins. Second, testing the physical and mechanical properties of the prepared epoxy EPO blend composites, where the tensile test and isotope impact test will be carried out. Third, characterizing the thermal properties of blended composites by using Fourier transform infrared spectroscopy (FTIR) and thermogravimetric analysis (TGA) to achieve the objectives.
Significance of the study. The finding of the study could give one of the environment-friendly alternatives in manufacturing thermosets in using natural fiber as starting materials or blending components. This study also will be starting point of any in-progress research in the issues of mixing components by using empty fruit bunch fiber, epoxy and EPO composites.
Those are the previous studies that shows about the effect on mechanical and thermal properties of the natural fiber reinforced composites, which could support this study. In this study, the natural fiber, which is empty fruit bunch with the different sizes 1 cm, 2 cm and 3 cm, that will be used as reinforcement in epoxidized palm oil composites. The fiber will be treated with the sodium hydroxide. Next, the mixture of epoxy, EPO will be added hardener. Then the treated fiber will be mixed together with the epoxy EPO composites and then we lay on the open mold. Lastly, the curing process will be done by doing the pre-cured at 80 degrees Celsius for 2 hours and for the post-cured process occur 110 degrees Celsius for another 2 hours in the oven. The description of mechanical and thermal properties will be recorded where the tensile test, impact test and a thermogravimetric analysis will be conducted.
Those are the sample preparations for fabrication process at Makmal Bendale UMT. Results and discussions for mechanical properties, tensile strength. Those are the effect of fiber size on tensile strength of EFP reinforced epoxy EPO composite. The tensile strength of both knit epoxy and epoxy EPO composites improved until it started to decrease after it exceeded 2 cm fiber size. This situation happens as the fibermetric adhesion weakens and the amount of fiber content exceeds the metric, so the properties deteriorated. Ramli 2011 stated that the decreased result in tensile strength occurred due to the composite matrices and the AFP fibers' weak interfacial adhesions or interaction. Moreover, irregularly shaped fibers such as EFB fiber with shorter fiber length employed in the study may not be able to withstand stresses imparted from the polymer matrix, resulting in a decrease in tensile strength as the fiber sizes was increased. Next, clearly between knit epoxy and epoxy EPO composite have a quite different gap. In the presence of the high amount of EPO, weak spots may exist at the end of the free chain for the nucleate voids. Next, mechanical properties of tensile modulus or Young's modulus. Those are the effect of fiber size on tensile modulus or Young's modulus of EFP fiber reinforced epoxy EPO composite. As seen in the graph, both readings of the Young's modulus followed the same pattern as the tensile strength. At first, the value of tensile modulus increased, then decreased as the fiber size increased at 3 cm. If the Young's modulus is high, the material could be termed rigid or stiff. Based on the theory from the previous study, as the fiber size increased, the modulus also gradually increased because the fibers are stiffer than the matrix. Based on the tensile modulus result in this study shows that the fiber size of 2 cm are the most rigid for both knit epoxy composites and epoxy EPO composites. Next, mechanical properties of elongation at break. Those are the effect of fiber size on elongation at break of EFP fiber reinforced epoxy EPO composites. The graph shown that the higher size of fiber, the lower the elongation at break. From the observation of the graph, the epoxy EPO composites are more significant rather than the knit epoxy composites. Free chain ends may provide weak spots for nucleating voids under stress at amount of EPO, reducing elongation at composite break. Another explanation is that the EPO reduces intermolecular forces and increases rubber chain mobility, improving the flexibility of rubber and EPO blends. Furthermore, according to Blatzy 1998, there is a crucial fiber length in short fiber reinforced composites that must be met for the fiber to achieve its completely strained condition in the matrix. If the strained fiber is shorter than the critical length, it will be adhered from the matrix, resulting in fiber breaking at low composite strength. Results and discussions for thermal properties, thermogravimetric analysis, TGA. TGA result shows a curve of weight loss variation with temperature. Based on the data result for all samples are slightly similar to each other. From the observation on the graph, mass loss slightly under the 200 degree, which could be attributed to absorbed moisture evaporation. Even though the fiber was dried up in oven before running the TGA analysis, the moisture begins to evaporate at a temperature of 80 degree because it is difficult to eliminate water. The graph also shows the hemicellulose decomposes between 200 and 500 degree. Those result range data could support the findings of Azwa 2013, who discovered that the hemicellulose decomposes between 135 until 400 degree. Based on the TGA curve, both the neat epoxy composites and the EFP fiber reinforced epoxy EPO composites have the same pattern of thermal stability. However, the neat epoxy slightly high thermal stability rather than the EFP fiber reinforced epoxy EPO composites. This makes the most thermally stable are the neat epoxy. This happened because of the greater EFP epoxy interaction and the properties of the fiber are easily combusted. Thus, it shows that the composites that contain fibers have low thermal stability. As a conclusion, this study will achieve all the objectives based on the following result. First, the fabrication process for empty fruit bunch EFP fiber reinforced epoxy EPO composites was achieved by using the open mold technique. Second, the mechanical properties for the composites, the tensile strength and the tensile modulus are gradually increased as the fiber size increased. However, the results start decrease as the fiber size exceeded 2 cm. This happened due to the fiber content exceeds the matrix and the fiber matrix adhesion weakens. Since the EFP fibers can resist a larger size while spreading a smaller size to the epoxy matrix, composites reinforced with EFP fiber have a better tensile strength and a Young's modulus than the neat epoxy composites. As for the elongation at break, neat epoxy composites have more elongation at break than the EFP fiber reinforced composites due to their lower tensile strength and modulus. Third, according to thermogravimetric analysis (TGA), as compared to EFP fiber reinforced composites, neat epoxy composites have significant thermal stability in view of the fact that happened due to the fiber resistance made the composite less thermal stable since the character of the fiber itself were easily combusted. For further study recommendation, this study is expected to provide a collection of facts and information that will encourage further research into other natural fiber composites, such as kenaf, flax, sugarcane, and jute fibers. To widen the application range of EPO biocomposites, it is also advised that the difficulties of heat stability and moisture absorption to be addressed. The development of green composites and nanocomposites from oil palm as well as the utilization of natural-based resin polymers with improved mechanical properties for sustainable materials and manufacturing will be focused for further study.
Those are selected references in these studies. That's all from me. Thank you.